All right, here's a video for the Unit 6B practice test. So number 1 says graph the function using any method. We're going to use at least 5 points. So first thing we want to do is identify the characteristics of this function, and then we're going to go ahead and graph it. So first, starting with the concavity, well, in this graph, we know that it is concave up since the value of a is positive. So we know it's concave up. And then the next characteristic we can get pretty easily from the equation without having to do any calculations are the x-intercepts, since this is in factored form. So our x-intercepts, we're going to look inside the parentheses, and we basically need to say what would x need to be in order to make this 0. So we know that x would have to equal 2, which means I have an x-intercept at 2, 0. And then looking at the second parentheses, what would we need, what would x need to be in order to make this parentheses 0, and that would be negative 4. So my other x-intercept is negative 4, 0. Once we have that, we're going to go ahead and figure out what our axis of symmetry is, because that's going to be our line of reflection. And in factored form, the easiest way to find our axis of symmetry is to add our x-intercepts and divide by 2, which is going to give us the middle of our x-intercepts. So 2 plus negative 4 is negative 2 over 2, which is negative 1. So my axis of symmetry is negative 1. And since I have that, I also have half of my vertex. So my vertex is going to be negative 1, comma, and then to figure out what the y value is, we're going to plug in negative 1 for x. So negative 1 minus 2 and negative 1 plus 4. Well, negative 1 minus 2 is negative 3, and negative 1 plus 4 is 3, so that gives me negative 9. So my vertex is going to be negative 1, 9. Now that we have that, we're going to go ahead and plot all those things. The first thing I'm going to do is I'm going to plot my vertex. So negative 1, negative 9. I'm going to graph my axis of symmetry since that's going to be our line of reflection. I'm going to go ahead and plot my x-intercepts. So I have one at 2, 0 and negative 4, 0. And since it says use at least 5 points, we need to pick one other point. So to pick another point, we're just going to pick something near our vertex. So we know we have nothing, we have a value at negative 1, so let's just go 1 to the right and see we don't have a point on our parabola where x is equal to 0. So I'm going to plug in x equals 0. So that means my point is going to be 0, comma something. So then plugging 0 into here, I have 0 minus 2 and 0 plus 4. So I have 0 minus 2 and 0 plus 4. So that's negative 2 and 4, which gives me negative 8. So my point is going to be 0, negative 8. And once I have that, I can reflect it over to get its symmetric point, which is going to be right here. And the coordinates of that point is going to be negative 2, negative 8. So now that I have that, I can go ahead and connect my points and sketch my parabola. All right, let's take a look at number 2. So number 2, we're doing something similar. However, this one is in vertex form, but we're going to start the same way. We're going to list out our characteristics. So I'm going to go ahead and do it here. For this one, we know it's concave down since a is negative. The characteristic we can get from standard form is our y-intercept, which is going to be 0, 6. We're going to find out our axis of symmetry, which in standard form we know is negative b over 2a. So b is 4. So negative 4 over 2 times a. That becomes negative 4 over negative 4, which is positive 1. So my axis of symmetry is x equals 1. And then I have half of my vertex. To get the other half, we're going to plug in 1 to our equation. So negative 2, 1 squared, plus 4 times 1, plus 6. Okay, so we can put that in our calculator, or we can kind of figure it out using a little bit of mental math. So parentheses first, so 1 squared is 1. And then we multiply that by negative 2. So this whole first term becomes negative 2. And then 4 times 1 is 4, plus 6. And then going from left to right, negative 2 plus 4 is 2, plus 6, we get 8. So my vertex is going to be 1, 8. All right, so now let's go ahead and graph these. So I'm going to graph my vertex first. I'm going to go ahead and graph my axis of symmetry. And then I'm going to plot my y-intercept. So my y-intercept is 0, 6. And since we have that, we know we have its symmetric point. So I'm going to reflect it. And I get my point at 2, 6. So now we have 3 points. We just need one more point. So again, we're just going to choose something near our vertex. So here's our vertex. If we go 1 to the right, we already have a value for x equals 2. So let's go ahead and plug in 3 to our equation. So for our point, we're going to plug in x equals 3. So my point is going to be 3, comma, and then to get the y value, we're going to plug it in to our equation. So negative 2 times 3 squared plus 4 times 3 plus 6. So again, let's do this piece by piece. So first thing I'm going to do, 3 squared is 9, and 9 times negative 2 is negative 18. 4 times 3 is 12, plus 6. And then going from left to right, negative 18 plus 12 is negative 6, plus 6 gives us 0. So my point is going to be 3, 0. And if I have that point, I have its symmetric point, so I'm going to reflect it over. And that's going to give me the point. Oops, I went a little too far over. Negative 1, 0. All right, so now for number 3, we have a parabola written in factored form. So we're going to graph again using 5 points. So we're going to start with a concavity, and we know it's going to be concave up since the value of A is positive. Then we can list out our x-intercepts. And to do that, we look inside the parentheses, what can x be to make this 0? So x would be negative 5. So we have an x-intercept at negative 5, 0. And for the other parentheses, we would have one at negative 7, 0. So using our x-intercepts, we can calculate our axis of symmetry, which we're just going to find the midpoint of our x-intercepts. So we're going to add our x-intercepts and divide by 2. So that becomes negative 12 over 2, which is negative 6. So our axis of symmetry is x equals negative 6. And then we have half of our vertex. So it's going to be negative 6. And then to get the y value, we're going to plug in negative 6 for x in both equations, or in both parts of the equation. So it's going to be negative 6 plus 5 and negative 6 plus 7. So this becomes negative 1 times 1. We get a value of 1. So my vertex is going to be at 6, 1. So using these characteristics, we can start to sketch a picture. I'm going to plot my vertex first. So negative 6, 1. I'm going to graph my axis of symmetry since that's going to be our line of reflection. I'm going to plot my x-intercepts. And now we need one more point. So again, we're going to choose points that are near my vertex. So if we go 1 to the right, we see we already have a value or a point on our parabola where x equals negative 5. So let's just go one more over, and we're going to plug in negative 4. So for my third point, for my fourth point, we're going to plug in the value x equals negative 4. So my coordinate is going to be negative 4, comma, and then we're going to plug it in just like we did for the vertex. So it's going to be negative 4 plus 5 and negative 4 plus 7. So negative 4 plus 5 is 1, and negative 4 plus 7 is 3, and 1 times 3 would give me 3. So my point is going to be negative 4, 3. And once we have that point, we can actually reflect it over to get its symmetric point, which is going to be right here, and the coordinates of that is negative 8, 3. All right, So now let's look at number 4. So standard form, we're going to start off by listing the concavity. So the concavity for this one is going to be down since A is negative. Since it's in standard form, we can list our y-intercept. That's going to be 0, -3. We can calculate our axis of symmetry, which we're going to do negative b over 2a. So negative 6 over 2 times -1. So that's negative 6 over negative 2, which is going to give me 3. So my axis of symmetry is x equals 3. And since I have that, I have half of my vertex. To get the other half, we're going to go ahead and plug in 3 to our equation. So negative 3 squared plus 6 times 3 minus 3. So doing this in parts, so we're going to first look at the parentheses. So 3 squared is 9, and we're multiplying that by a -1, so that's -9. 6 times 3 is 18, and then we have minus 3. And then going from left to right, -9 plus 18 is 9 minus 3. That gives me 6. So my vertex is going to be 3, 6. All right, so let's go ahead and graph those points. So 3, 6. And now we're going to plot our y-intercept. And we can actually reflect that over. It's going to give me the symmetric point here. The coordinates of that point is going to be 6, -3. And now we need one more point. So choosing a point near our vertex. So from our vertex, I usually like to go right and see if we have a coordinate for that particular x value. So looking up and down, I don't have a point. I know it's going to be somewhere in this area, but I don't know what it is. So I'm going to plug in x equals 4. So to get the y coordinate, we're going to plug it in just like we did for the vertex. So -4 squared plus 6 times 4 minus 3. So starting with the parentheses, 4 squared is 16, and multiply that by -1, so that's -16, plus 6 times 4 is 24, and then minus 3. And then going from left to right, -16 plus 24 is going to give me 8, minus 3 gives me 5. So my point is going to be 4, 5. And I can reflect that over to get its symmetric point, which is going to be right here, and the coordinates of that is 2, 5. So there I have my 5 points. I can connect the dots and form my parabola. All right, so for the next set of problems, we're going to be using A, H, and K to describe the specific transformations from the parent function, and then we're going to graph using transformations. So if you feel like there's not enough room on this piece of paper, definitely do the transformations, write out the transformations on a separate sheet of paper. I'm going to try and squeeze it in here as best as I can. All right, so first thing I'm going to do is I'm going to figure out what A, H, and K is. So for number 5, A is going to be -1. H is going to be -2 because it's the opposite of inside the parentheses. And then K is going to be +4. So in terms of describing the transformations, remember that A tells you two things. A tells you whether or not there's a reflection. Again, we're talking about in relation to our parent function. So if A is negative, that tells me that there is a reflection. Okay. And then the number will tell us whether there's a stretch or compression. Well, remember in our parent function, the value of A is equal to 1. So that means if A is positive or -1, that means there's no stretch or compression. Okay, H tells us whether or not there's a horizontal translation. So since H is -2, that means there's a horizontal translation. And since it's negative, we're going to go left 2. And then K gives us a vertical translation. And since it's positive, that means we're going to go up 4. So I'm going to go ahead and plot my parent function. So remember the pattern is over 1, up 1, over 2, up 4, and over 3, up 9. And we can continue going on if we wanted, but that would take us off the graph. So I'm just going to use a dotted line to show our parent function because we're doing our transformations in relation to our parent function. So first thing I'm going to do is a translation. So I'm going to go left 2, and I'm going to go up 4. So my new vertex of my parabola is going to be right here. So now we're going to graph using A. So in our parent function, remember that we went over 1, up 1. But since A is negative, that means we're actually going to go down 1 instead. So from my vertex, I'm going to go over 1, and I'm going to go down 1. So my new point is going to be right here. And I can get its symmetric point on this side. Then the next point to graph, I would go over 2. Normally in my parent function, I would go up 4 to graph it, but since there's a reflection, I'm actually going to go down 4 instead. So from my vertex, over 2, and I'm going to go down 4. So 1, 2, 3, 4. So my next point is right here at the origin, and I can get its symmetric point right here. So let's graph one more. So next in my parent function, I would go over 3. 3 squared is 9, up 9 to graph my next point. But since A is negative 1, I'm actually going to go down 9 to graph my point. So from my parabola over 3, 1, 2, 3, and I'm going to go count down 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So my new point is going to be right here. And then I can find its symmetric point on the other side. So now I have my graph. I'm going to go ahead and label it. So that's negative x plus 2 squared plus 4. So as we can see, we took our parent function here. We shifted it left and up. These were these translations. And then I reflected it across the x-axis, which made it concave down. And then since there was no stretch or compression, it should be the exact same width of our original parabola. All right, so now let's take a look at number 6. So just like before, I'm going to identify A, H, and K. So A is 2. H, we look inside the parentheses and it's the opposite sign, so that's going to be positive 1. And then K is the number on the outside, that's going to be negative 3. And then let's describe the transformations. So since A is positive, that means there's going to be no reflection from our parent function. And then since A is 2, that means there's going to be a vertical stretch of 2, which means our parabola is going to be more narrow than the parent function. So H is 1, which means we have a horizontal translation. It's positive, so we're going to go to the right one. And then since K is negative, that means there's a vertical translation down 3. So now I'm going to go ahead and sketch my parent function. So starting at the origin, we go over 1, up 1, up over 2, up 4, and then over 3, up 9. So we know our parabola is going to be skinnier than this one, and then we're just basically moving it around. So it's going to be facing the same direction. It's going to be concave up, but it is going to be a more narrow parabola. All right, so first thing I'm going to do is graph the translation. So I go right 1 and then down 3. So my new vertex is going to be right here. And then we're going to go ahead and use the value of A to graph my parabola. So in our parent function, we go over 1, up 1, over 2, up 4, and over 3, up 9. But since our value of A is equal to 2, we're going to multiply. That's a vertical stretch, so we're going to multiply our y, our vertical distances by 2. So we're going to go up 2, up 8, and up 18. So starting from our vertex, I go over 1. Normally I would go up 1, but since I'm stretching it, I'm going to go up 2. So my next point would be right here, and I can get its symmetric point here. And then my next point, I would go over 2. Normally I would go up 4 for my parent function, but I'm doubling my distance, so I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. So my new coordinate is right here, and I can get its symmetric point on the other side. And then my next point, actually I think it's going to take it off the graph. So since it's probably going to take it off the graph, I'm okay with at least 5 points here. So I'm going to go ahead and connect these. And as we can see, our graph is a little bit more narrow than our parent function, and we just shifted it right and down. All right, so now taking a look at number 7. First, we're going to identify A, H, and K. So A is 1/2. H is going to be positive 3. And K is negative 1. All right, so now talking about the transformation. So looking at A, it tells us two things: whether or not there's a reflection. Since it's positive, that means there's no reflection. And it tells us if there's a stretch or compression. So A is 1/2, which means it's closer to 0, which means there's going to be a vertical compression of 1/2. H, we know there's a horizontal translation. Since it's positive, we're going right 3. And then K is negative 1, which means that there's a vertical translation, and we're going down 1. All right, so now let's go ahead and graph. Again, I'm going to start with my parent function just so I can have a reference for my graph, since all the transformations are in relation to our parent function. Okay, so now let's go ahead and graph. I'm going to do the translation first. So I'm going to go right 3, and I'm going to go down 1. So I have my new vertex. And then we're going to use the value of A to graph. So in our parent function, we go over 1, up 1, over 2, up 4, over 3, up 9. But since A is 1/2, I'm going to multiply my vertical distances by 1/2. So for my first value, I'm going to go up 0.5. My second one, I'm going to go up 2. And my third one, I'm going to go up 4.5 to graph my parabola. So this should create a parabola that's wider than our parent function. So starting from my vertex here, I'm going to go over 1. Normally in my parent function, I would go up 1, but I'm going to go half as much since I am compressing my graph, which would give me a point right here. And I can get its symmetric point right across. So my next one, from my vertex, I would go over 2. Normally I would go up 4, but since it's a compression, I'm going to go up 2. 1, 2. So my next point would be right here, and I can get its symmetric point on the other side. And then for my parabola, to get my third point, I would go over 3. Normally I would go up 9, but I'm going to go up half as much, so 4.5. So 1, 2, 3, 4.5, which would put me right here, and its symmetric point would be right across. So we could keep going if we want, but I think that's enough to graph my parabola. So as we can see, we have a parabola that is wider than our parent function, and then shifted right and down. All right, now with number 8, this number got a little cut off, but it's 1/2. Again, listing out A, H, and K. So A is negative 1/2. H is going to be negative 2. And K is positive 2. So A tells us two things. Since it's negative, that means there is a reflection. And because it's 1/2, comparing that to our parent function of 1, it's less than 1, which tells me that there is a vertical compression of 1/2. H tells me horizontal translation, and in this case, we have a horizontal translation left 2 units. And then K tells me the vertical translation, so we have vertical translation up 2 units from our parent function. So graphing our parent function, just as a reference. So this one I'm not even going to connect the dots on my parent function. I'm going to do my translation. So from here, I'm going to go left 2, and I'm going to go up 2. So that puts me at my new vertex right there. And then we're going to use the value of a. So again, in my parent function, I normally go over 1, up 1, over 2, up 4, and over 3, up 9. Because 1 squared is 1, 2 squared is 4, 3 squared is 9. But since a is negative 1/2, I know I'm going to be going down instead, and I'm going half as much. So that means I'm going to go down 1/2, down 2, and down 4.5 to graph my new function. So from my vertex over 1, and I'm going to go down 1/2. So my next point would be right here, and then I have its symmetric point. And then from my vertex, I'm going to go over 2. Normally I would go down 4, but I'm going to go down half as much since I'm compressing it. So I'm going to go down 2. And I have its symmetric point. And then from my vertex, I would normally go over 3. 1, 2, 3, and I would go down 9, but I'm going to go down half as much. So 1, 2, 3, 4, and just a half. So I have my symmetric point. So there's my parabola, wider than my parent function since it's being compressed, and just shifted left and down. So this is negative 1/2 x plus 2 squared plus 2. Okay, so now with these last few, we're going to be basically working backwards, figuring out what our parent function is, or what our function is based off the graph. All right, so we know our parent function starts at 0, 0. So let's figure out how far our vertex has shifted. So it looks like we went right 2 and up 3 to get to my vertex. So that means that h is going to be 2, which means there's a horizontal translation right 2. And then k is going to be 3, which means there's a vertical translation up 3. So now let's figure out what the value of a is. Well, clearly we can see that our graph is concave down, which means that there's been a reflection. So we know that a has to be negative, and we know that that means there's a reflection across the x-axis. Since we know that our parent function is concave up. So to figure out the value of a, we need to see if it seems like it's been stretched or compressed. So looking at our vertex here, we're going to compare it to our parent function. So parent function, we normally go over 1. If it's the same as our parent function, all we would have to do is go 1 unit down to get to our parabola. And in that case, we do. We hit our parabola here. So over 1, down 1. And then the next point, go over 2. 2 squared is 4. So if we go 4 units, we should hit our parabola. 1, 2, 3, 4. We hit our parabola. So the vertical distances is the same as our parent function, which tells me that the value of a is going to be the same as our parent function. So a in this case is just going to be a negative 1, which tells me that there's no stretch or compression. So now I can write my equation. So f of x, it's going to be negative 1 out in front. So negative x, we went right. So it's going to be minus 2, and then up plus 3. All right, now let's take a look at number 10. So again, first figuring out what our translation is. So to get to my vertex, I need to go right 4, up 1. So right 4 tells me that h is positive 4, which means there's a horizontal translation right 4. K, we went up 1, which means k is positive 1. So that means there's a vertical translation up 1 unit. And now figuring out the value of a. Well, we see that our graph is concave up, which means A is positive, which means that there's no reflection. And then again, to figure out whether there's a stretch or compression, we're going to see how this parabola is graphed. So when we go over 1, all we have to do to get to our parabola is go up a half. Normally in our parent function, we would go up 1 whole unit, but we're going half as much. So let's check the next one. We go over 2. To get to our parabola, we have to go up 1, 2. Normally in our parent function, we would go up 4, so it seems to be half as much, which means the value of A is actually going to be 1/2. So this graph is wider than our parent function, which means A is 1/2, which means that there's a vertical compression of 1/2. Okay, so now that we have our values of A, H, and K, now we can write our equation. So f of x equals 1/2 x minus 4 squared plus 1. All right, now with number 11, we're going to start off by doing our translation. So from our parent function, to get to our new vertex, we went right 3, up 3. So that's going to give me the value of h. So that means there's a horizontal translation, right 3. And then k was 3, which means that there's a vertical translation, up 3. And then to get the value of a, it's concave up, so I know it's positive, which means that there's no reflection. And then to figure out the value of a, we're going to look and see how our parabola was graphed. So starting from our vertex, when we go over 1, it takes 2 units to get to my parabola. Normally in our parent function, it would only take 1. To get my next point, I go over 2. Normally I would go 2 squared is 4. It would take me 4 units to get to my parabola, but in this case it takes 1, 2, 3, 4, 5, 6, 7, 8. So since those vertical distances are double what we would normally see in our parent function, that tells me the value of a is going to be positive 2, which means that there's a vertical stretch of 2. So now that I have that, I can write my equation. It's going to be f of x equals 2 x minus 3 squared plus 3.